Hi everyone, my name is Muhammad Zulfika and I will present about the introduction. In this project, we need to propose the pedestrian bridge for the pedestrian to cross the river. This project I require to use the Prestress concept. This bridge is located to the next Tun Razak bridge at Batu Pahat Johor. The image shows that the location through Google Maps. We move to the plan view. It has 60-meter length of the bridge with 2 meter of width. Next is the elevation view. It has 3 components. First one is the superstructure, which consists of handling, box girder, abutment, and roof. And second is for substructure, is content of rectangular columns. And lastly is the foundation components. Next is the side view. It consists of box girder details. Next is the design specification and the properties. For the first table, it shows that the dimension of the box girder clear spans, precast column size, and the column height. Next table shows the material properties, which consists of compressive strength FCU, FCI, yield strength FYK, Young modulus, and lastly strength of cable, which is 12 tendon of each 3 duct. And last table shows the loading used in this project. For the dead load, it includes of unit weight of concrete, floor, finishes, railings, and roof. For the live load, it used distribution load at 400 kg per meter cube per meter square.
Hi guys, my name is Tun Razak and now I would like to present our manual calculation for our project. So first of all, we have to propose a dimension for our box girder. So we have a 2000 millimeter width on the top, which serves as the pedestrian bridge width. And then we have 1100 mm on the bottom. And then we have a total height of 960 mm. So for the calculation, first we are going to determine the area of the box girder. So we get 943,000 mm square. And next we are going to find the location of neutral axis. So it is from the bottom 560.12 mm. So in our case, we are going to use post tension class 2. Next, we are going to determine the moment of inertia IYY, and we get 9.69 times 10 power of 10 millimeter power of 4. Then for the loading, so according to the standard, the live load is 3.92 kN per meter square, and we can assume our own the dead load, the self weight of the box girder, the roof we assume as aluminium material, and the rear beside the bridge, and the finishes is 1.2 kN per meter square. So after that, we have all the loading, we can calculate the MI and the MS. And after that, we are going to check for our ZT and the ZB using the equation that provided below.
Hi everyone, my name is Tan Hui-Ling. So now I would like to present about the Magnol diagram and cable profile. For the Magnol diagram, the substitution of value into the 4 inequalities for the prestress force yielded a range of possible values for prestress force and eccentricity as shown in the table. Next, the value obtained from 4 equations were plotted and Magnol diagram is formed. From the Magnol diagram, the eccentricity of 150 mm is chosen and substitute in the equation B and equation D. The range of allowable values are in between of 6252.74 kN and 7763.98 kN. Thus, the prestress force chosen was 7279.65 kN. For the cable zone, 4 inequalities were formed by substituting prestress force obtained from Magnol diagram. 2 inequalities were chosen for further calculations for cable profile. The substitution of value into the 2 inequalities for the eccentricity yielded a range of possible values for moment at transfer and moment at service as shown in the table. Next, the cable profile shows that the maximum eccentricity is in between 124.5 mm and 162.01 mm. So the drawn strand of 15.2 mm diameter with breaking load of 300 kN was proposed, and the initial prestress was assumed to be 63%. Thus, the number of tendon required is 39 numbers with 15.2 mm diameter in 1 meter run.
Hi, my name is Violet Lang. So now I'm going to present about the ultimate moment resistance and shear resistance checking. First is eccentricity checking based on Manon diagram. The eccentricity at end span is 0 and mid span is 159.8 mm within allowable range. Then the ultimate moment resistance is determined by using stress strain curve method. 13 tendons in each drug and total area of 39 tendons is 5,421 mm square. Effective pre-stress force is 4,278 kN, so the stress strain graph was plotted in accordance with the formulas. Here is the stress strain graph. The calculated moment resistance is 3,889 kN, which larger than the actual moment 1,369 kN. Therefore, the design is safe for moment checking. Here is the detailing. Next is check for ultimate shear resistance. It was calculated for 10 to 50% of span length. Firstly, draw shear force and bending moment diagram. Here is the shear force diagram. Next is check for maximum allowable shear stress. Then calculate MO and plug it in bending moment diagram. When MO is less than actual M, the section is cracked in fracture. According to the result, the section is uncracked from 0 to 3 meter and cracked in fracture from 4.5 to 7.5 meter. So here is the bending moment diagram. Next is determine ultimate shear resistance. For uncracked region, shear resistance is equal to VCO plus VP, while for cracked region, VC is the smaller of either VCO or VCR. Then the shear force of all the sections were less than 0.5 VC, therefore shear reinforcement is not required after checking. However, the nominal link is provided for enhanced safety. After checking, 10 mm diameter link at 200 mm spacing was used. Here is the detailing of shear reinforcement.
Next part is on the defection and end block design. The defection are calculated into short and long-term defection. Self-weight loadings and prestress force before losses are considered at transfer, while self-weight plus total service loading and prestress force after 25% losses is considered as service, with both being negative 2.22 and 2.12 mm respectively, complied to the allowable deflection at 60 mm. Next, self-weight plus finishes plus 30% of variable loading contribution and prestress force after 25% losses were considered in long-term deflection. The effective elastic Young modulus of elasticity is 13.93 kN per millimeter square. The long-term deflection is 13.68 mm, complied to the allowable at 60 mm. Checking force to each anchorage is 1,426 kN, and the actual steel bearing plate was checked and complied with the allowable steel bearing plate. For individual prism at vertical and horizontal direction, the maximum buffeting force is 200 kN and the required steel area is 500 mm square. Therefore, for 10 mm bar is provided through a distance of 200 mm at vertical direction. For overall prism equivalent, the length of a side of bearing plate is 300 mm and the maximum buffeting force is 984 kN and the required steel area is 2,459 mm square. Therefore, 16 mm bar is provided through a distance at both direction since they have the same value.
Now we go for the detailing. This is the detail of the plan view. The dot line shows the column location and the black shaded shows the handling. Next is the elevation view. It consists of 3 components that I mentioned in the previous presentation. Next is the box girder detail combined with column and the foundation details. Next is the dub detail. It shows that consists of middle cross section and end section. And second one is the reinforcement detail by using shear link at size of 10 diameter. And now we go for the last part is the conclusion. This project is success, although there might be several errors obtained in calculating the design on the structures. And we also managed to cooperate as a team conducting this project and increase our knowledge in manual calculating and software related to pedestrian bridge. It can be concluded that the structure proposed is stable and suitable for arrangement and loading for the structure system based on the design manual calculation. That's all for us. Thank you.